So good afternoon, everyone. So this is again THWX3 Meeting, and technically nasa week 12 na tayo, which is on union find and minimum spanning trees. But yung coverage ng ating meeting for today will be on week 11, which is yung shortest path algorithms. So obviously, before tayo mag-start, let's just have a quick look no ating schedule. So, ayun. So, we are now on week 12. And after this week is another week on algo analysis. And we've actually decided to make this optional. So, actually, lahat i-release namin yung materials on this, but yung assessments will be optional. So, bakit namin siya gagawing optional? Because yung release ng software project will also be, I think, tomorrow or Saturday. And that is to give you 1, 2, 3, 4 weeks in total for the software project. And ayun. And we've actually decided doon sa after 2 weeks, magkakaroon ng midway checking nung software project. So parang lahat kami ginawa yung software project in such a way na merong halfway point or yung 50% or 50% milestone na hopefully matapos nyo by the middle no ating period for the software project para hindi tayo naghahabol ng oras by the end. And then ayun, ang software project din ay instructor specific. So so for THWX3 and THYZ2, we will have one software project. So pag magtanong kayo sa ibang sections, there will be different specifications and problems. Although last week nag-meet naman kami and we looked at each other's software projects, and to some degree parang either yung solution no ng software project is a modified version nung standard na algorithms provided, or it is a combination of two of the standard algorithms pero wala masyadong modification to each. So yung parang pag-integrate yung problem doon. So either one of those two yung parang general gist nung problem. And of course, iba-iba yung context nila. So parang almost nagkanya-kanyang storya lang din kami. Then, actually, I think I can say na parang may specific algorithm per instructor. I guess yung favorite algorithm ng instructor yung naging focus ng software project nila. Pero basically yun, meron isang core or dalawang core na algorithms na either i-combine or i-modify with in relation doon sa software project. And ayun, ang tentative na deadline ng software project, I think yung working deadline namin is set to June 4. So yung last day ng finals week. And then for lead submissions ng software project, unfortunately, since malapit na siya sa deadline of grades, unless valid concern talaga, we will not be granting late submissions. I guess kung gusto nyong hindi ma-incomplete, submit nyo na lang kung ano yung natapos nyo. Although yun nga, kailangan nyo maka at least 50%. Although, ayun, ginagawa ang parang instruction or yung parang ginawa rin namin is that yung first 50% will be relatively easier dun sa last 50% ng software project. So parang madali lang makukuha yung first 50% para hindi or para ma-achieve yung requirement na 50% per each component ng ating grade. And then with regards to yung late submissions in general, actually nagpagawa na sila ng departmental na announcement since nag-base siya doon sa ginagawa ko sa ating section. So, yung ibang handlers din, actually, ito rin yung ginagawa. Although baka nag-iba ng konti yung numbers, pero yun. So, basically, this is yung policy natin ever since we started. So, grade cap of 80%. Pag within 1 week after the deadline, if 1 week or more after the deadline, yung cap will be 60%. So, and then, ayan, so before we proceed, are there any questions regarding our schedule and yung ating future activities, software project? Yeah, I guess if wala, ayun, pagka-release naman ng specifications, we'll have a synchronous session din siguro para i-discuss yung i-release na specifications for the software project. So, I think that will be in 2 weeks para makapag-meet tayo for week 12 next week. So, ayan. Without further ado, let's go to week 11, excuse me, which is on our shortest path algorithms. So, actually, meron tatlo. Dijkstra's, Bellman-Ford, and Floyd-Warshall. And actually, apat talaga if you consider yung breadth first search na algorithm or yung breadth first search na siya actually yung, in my opinion, siya yung naging basis ng lahat ng ibang algorithm except possibly yung Floyd-Warshall. Pero para lang siyang modified breadth first search. So ano nga ulit yung breadth first search? So siya yung starting from yung ating root node or yung starting node, parang visit lang natin lahat ng mga katabi niya. And then, after ma-visit ng mga katabi niya, i-visit natin yung mga katabi ng katabi niya. So, instead of yung depth first search, parang mag-branch tayo hanggang makarating sa dulo. Sa breadth first search is lahat muna ng malalapit yung binivisit natin. So, since nauuna yung mga mas malapit, pag mas maagang nadaanan sa breadth first search, mas maikli yung path. Although gumagana lang to pagka, ayun pala, if unweighted yung ating graph, such that parang 1 hop, 2 hops. So parang in terms of hops lang yung distances ng ating nodes. Yung breadth first search is actually a valid shortest path algorithm. So parang titingnan mo lang kung yung previous node mo, ano yung distance niya from the source. So parang ito, kunwari, from 0 from the source. So yung distance ni source sa sarili niya is 0 kasi it's the same node. So yung kanyang mga neighbors, lahat sila distance 1. So yung isang neighbor si vertex 1 and si vertex 4. So pareho silang distance 1. So makikita niyo merong color red na 1 na nakapatong dun sa arrow. And then lahat naman ng neighbors ni 1, since 1 away siya from the source, lahat ng neighbors ni 1 will be 2 distances away. So si 2 at saka si 5 is 2 yung distance nila from the source. So, sure ka na ito yung parang shortest path niya kasi yun nga, nag-breadth first search ka eh. So, yung mga nauna mo na daanan, mas malapit kay source. So, you are pretty sure na ito yung magiging shortest path natin papunta sa mga nodes na yan. So, ayun, si 8 then is 2 hops away. And then, si 3, 6. And then may ginagawa siya dito, yung if tinitignan niyo yung pseudocode natin, tinatawag siya na relax or parang relaxation. So that's just basically updating yung mga neighbors na, uy, may daan from sa akin, galing sa source, and ito yung distance. So mas malapit ba to sa alam mo na distance? Kasi yun nga, initially lahat ng mga nodes natin, yung distance nila from our source is infinite kasi hindi natin alam kung gaano sila kalayo. And through relaxation, parang ito, in-update natin. So pag nag-relax tayo at node 5, sabihin ni node 5 kay node 1, okay, may daan si source papunta sa akin, yung distance niya is 2. Gaano kakalayo kay source? So parang, so si 1 is 1 distance away from the source, tapos si 5 ay 2 distances away plus 1 na hop. So, meron na akong daan papunta kay source na malapit. So, hindi ko kailangan yung distance na sinasabi ni 5. And then for node 6 naman, parang, ayun, sasabihin niya kay node 6. So may path ako from the source na distance 2. Gusto mo bang parang dumaan sa akin para umabot kay source? Yung magiging distance ng if 3. But since si node 6 ay meron na ring distance, may alam na siya na path na 3. Ayun, hindi niya titake. So kaya block pa rin to. Pero pagdating dito kay 10, parang sasabihin ni 5, yun nga, may daan from the source, papunta sa akin na distance 2. So, magiging distance 3 ka. Ayun, since si 10, initially alam niya, infinite siya, hindi siya nakakonect kay 0, to take ngayon as yung shortest path niya, papunta kay source. So, parang ganun. Then, similarly, si 8, check niya si 4, check niya si 9. So, yung pag-check natin ng mga distances is yung tinatawag na relaxation. And so basically sa breadth first search, kailangan na natin gawin yung relaxation for each node. And eventually, makikita natin na ito yung mga shortest paths natin from the source to the individual nodes. So from source 0, shortest path niya kay node 12 is 5 distance hops away. So 1, 2, 3, 4, 5. So, ayan. Unfortunately, breadth first search, hindi siya gagana pagka, or minsan hindi siya tama pagka yung graph natin is weighted. Ayan, pag tinry natin siyang i-breadth first search dito, yung kasing malalapit na nodes, kung wari ito, from 0 to 1 to 3, hindi naman necessarily, since pinaka-counting nodes na dinaanan siya yung shortest path. So, pwede kang dumaan ng 0 to 1 to 4 bago kay 33 and baka mas maikli yung path na yon. So, since weighted siya, hindi na natin masyadong sure. So, actually, pag tinuloy natin yung breadth first search dito, ayun, magkaka-warning tayo na yung shortest path papunta kay node 3 should be 26, not 33. Kasi yung, I think yung path na yun is from 12 plus 14. So, since nauna natin binisit si 1, parang since meron, tapos na tayo kay 2 eh. So, hindi na natin siya na encounter. If hindi kasi visited, is hindi na siya sinasama doon sa ating breadth first search na algorithm. So, yung improvement ng Dijkstra over yung breadth first search is nag-implement siya ng tinatawag na priority queue. So, yung assumption kasi ng breadth first search is lahat ng mga mas malapit, sila yung una nating binivisit. Pero hindi take into hindi natin na-account yung distances nila. So yung number of nodes lang in between. So di ba yung BFS gumagamit siya ng queue, di ba? So if nag-visit ko si 0, ma-add sa queue si 1 at saka si 2. And si 1 at si 2 yung mga next kong visit. So for Dijkstra, instead of using a regular queue, gagamit siya ng priority queue. So yung Dijkstra actually, it is a greedy algorithm in a way. Kasi yan, yung priority queue natin, so una nating i-visit si 1. Kasi siya yung mas malapit in 8. And then pagka, ayun naman, given yung mga current na nodes, sino yung pinakamalapit sa source? So yung pinakamalapit sa source na hindi pa na-visit is si node 12. And then ay si node 2 na may distance 12. And then i-relax natin lahat ng neighbors. Now yung kanina kasi nun sa breadth first search natin, una natin binisit si 2. Kaya una natin binisit si 1. Kaya yung na-assign kay 3 is already 26. So hindi siya nabago ni 2. But in this way, ayun. Pwede nang i-overwrite ni 2 yung assigned distance kay 3. And then Si 2 din, i-assign niya yung distance na kay 6. Then, titignan natin yung mga current na nodes. So, pinakamalapit kay source si 3. And then, ayun, basically, i-relax lang natin lahat ng neighbors. So, ayun, i-broadcast basically ni 3 sa neighbors niya. Meron akong path galing kay source na may distance sa 26. So, if you take ko itong path na to, si number 4, ikaw ay 46 units away. Number 5, ikaw ay 34 units away. Si number 6, ikaw ay magiging 38 units away. Pero si number 6, alam niya na, meron na siyang alam na path na 33 units away lang. So, hindi niya tatanggapin yung path galing kay 3. And then, yun. Si 7, and then si 8. Then, after nung ating node 3, check natin lahat ng nodes. Sino yung pinakamalapit kay source. So, pinakamalapit sa source is si 6. And then, i-relax lang natin lahat ng neighbors to 6. So, 33 plus 11 is 44. So, yung shortest path to 8 is ito pa rin. Yung dumadaan sa node 3. Then, next natin check si node 5. And actually, makikita natin na wala na masyadong magbabago niyan. And then, we have the shortest path from our source 0 to any of our other nodes. Eh, para take note lang na directed yung ating graph. So, hindi two-way yung mga to. So, ayun. So, yun na yung major difference ni. So, parang pwede mong isipin si Dijkstra para lang siyang breadth first search na merong priority queue. Kasi if you recall, yung breadth first search natin, gumagamit siya ng regular lang na queue. So, pag gumamit ka na ng priority queue, parang Dijkstra's algorithm na siya. However, yung problem sa Dijkstra's algorithm is, ang assumption niya is since dumaan siya sa mga pinakamalalapit na nodes, lahat ng mga pupuntahan nating other nodes is always going to be farther or mas malayo kasi positive lahat ng edge weights. Kaso pag may negative tayo na edge weight, let's see if merong may negative weight. Pag in-apply natin yung Dijkstra, I think magkaka-issue siya. Ayan, so makikita natin dito yung shortest path daw kay 4 is 6, which is yung path from 10 to from 2 to 3 and then 4. So bakit siya naging 6? Kasi yung assigned na path nung vinisit natin si 3. So here, vinisit natin si 3. So sasabihin niya kay 4, o yung shortest path mo will be through me plus yung edge between us, so 3. So sasabihin niya 6. So accept ni 4 yun. And then, tapos na tayo kay 3. So pagdating naman natin kay 10, ay kay node 2, vinisit natin si 3. Uy, meron pa palang mas maikling path papunta kay 3 na 0 lang yung cost kasi may negative tayo na edge weight. So, mag-update yung cost ni 3 to 0. So, kaso si node 3 or si vertex 3 na visit na natin, so hindi natin ma-update pa yung distance natin papunta kay 4. So actually, since medyo greedy nga yung algorithm ni Dijkstra, whenever may nag-update in the middle na visit na, is hindi na-update yung mga katabi niya. So, in order to address that, yung ginawa ni Bellman Ford is, what if instead of trying to minimize yung number of visitations, so parang for every iteration, ng algorithm is i-visit na lang natin lahat ng vertex. So parang uh, yung ginagawa ni Bellman Ford, similar siya sa Dijkstra, is dadaanan niya na lahat ng vertices pero hindi na siya gagamit ng priority queue. So dadaanan niya na lang talaga lahat. And then uulit-ulitin niya na lang 'yon hanggang wala nang nagbabagong edge weights or hanggang depende sa number of vertices yung iterations na basically. So parang, ayan, so visit niya si node 0 and then i-relax niya lahat ng neighbors niya. And then visit niya si node 1, visit niya lahat ng neighbors niya. Actually, for each edge list yung ginagawa dito. So yun, parang medyo matagal siya in a way. Kasi parang i-visit niya lahat ng edges. So parang yung una is update niya si 0 to 1. So yung distance ni 0 kay 1 is 1. Yung distance ni 3 pag dumaan kay 1 is 3. Tapos yung distance ni 4 pag dumaan kay 3 is 6. And then next naman ito, i-update niya. From source to 2 is 10. From 2 to 3 is 0. So yun yung first iteration natin. So dinaanan natin lahat ng edges. And then for the next iteration, parang check lang ulit. So from 0 to 1, yun pa rin. And then 1 to 3, yun pa rin. I guess yung 1 to 3 dito is 1 plus 2 plus 3, so hindi siya iti-take. So 0 pa rin si 3. Ngayon, ma-update natin si 3 to 4. Si 3 is currently 0, yung distance. And then ma-update siya to, yung 4 ma-update siya to 3. And then parang ulit-ulitin niya lang for each node. And ulit-ulit lang siya up to 4 times or yung number of vertices. So instead of using a priority queue para alamin kung sino yung i-visit na nodes, ang ginagawa ni Bellman Ford is dadaanan niya lahat ng nodes multiple times. So basically, ang gagawin niya is i-visit niya yung mga vertices for vertices. Kung 10 yung vertices, 9 times niya dadaanan lahat ng vertices. So bakit niya kailangan i-update 9 times? Kasi after 9 iterations, for sure, ma-account for na natin yung distance from a vertex 9 vertices away, basically. So parang, yung concept kasi niya is, kung wala nag-update yung shortest path papunta kay 3, it will take up to 1, 2, 3, 4 iterations bago umabot doon sa last vertex yung update na yun. So, I hope parang hindi masyado nag-make sense. Let's try ito, Bellman Ford killer. Yeah. Since ito yung worst case ni Bellman Ford, kasi yun nga, from the source is, ay, kailangan yung source natin ay 0. But parang hindi naman ito ba? So like, kailangan natin pasadahan lahat ng vertices one at a time. So parang actually wala naman. Ayun, nag-update. after each run, nag-update yung mga distances dito. So, ayun, in a way, parang kailangan mag-propagate nung, for example, ito na lang. Let's say yung shortest path papunta kay uh, 0 to 10 is actually yung pag-akyat baba dito. Pero, reset natin. Baka maging obvious naman na yung shortest path is yung pag-akyat baba. Pero yung initial na shortest path mo is from source to 10 dire-diretso dito sa baba since puro 0 naman siya. So pag Dijkstra yung ginamit mo, yun yung makukuha mo. But for Bellman-Ford, ang gagawin niya is, yun nga, after every iteration, may mag-update ng bagong distance. So, after the first iteration, makukuha natin yung distance papunta kay 2, which will be initially 0. After nung next iteration is magiging negative 16 siya. And then after niya maging negative 16, sa next iteration, doon pa lang ma-update yung mga katabi niya na meron pa lang mas maikling path. And after the next iteration, malalaman ni 4, meron pang mas maikling path, dadaan kay 3, and yun yung ipopropagate niya pa ulit. So parang medyo dumodoble yung pagbilang natin with the Bellman-Ford, pero it ensures na makukuha natin yung shortest path talaga. So, actually, one big comparison between yung Bellman-Ford and yung Dijkstra is that yung worst case time niya is v squared times e. Pero pag Dijkstra is v squared log e. So, pwede mo tong i-attribute, di ba si Dijkstra gumagamit siya ng priority queue. So, yun yung doon nakukuha yung log e. Pero si Bellman-Ford is instead of a priority queue is dadaanan niya na lang lahat ng nodes or lahat ng vertices multiple times. So, magiging linear siya with respect to e. So, ano yung problem pa kay Bellman-Ford and then kay Dijkstra din? So, yung problem sa kanila is they all assume na isa lang yung source natin. So, actually kaya sila single source na shortest path algorithms, they're assuming na isa lang yung source. So, pagdating sa Floyd-Warshall, it assumes yung multiple sources. So, yung Floyd-Warshall, actually, in my own words, para lang siyang nag-Bellman-Ford ka for each vertex. So, kung titingnan mo actually yung code dito, di ba? Parang for each vertex and then for each neighbor ng vertex, uulitin mo multiple number of times. Ang gagawin dito kay Floyd-Warshall is for each vertex and for each other vertex, parang multiple lang na, parang paulit-ulit lang na Bellman-Ford sa kada initial and final na destination. So, si Floyd-Warshall, magsiset up siya ng parang table ng distance from a starting and ending node. I'm not sure lang if meron example. Wala kasi dito. So, we can actually look at yung sa implementation na binigay. Basically, ang nangyayari dito is meron na tayong graph. You can actually draw it. So, ito naman pa. 0 to 1. We have 7. And then 0 to 3. We have 5. And then 1 to 3. We have 9. And then 1 to 2. We have 8. 1 to 4. We have 7. 2 to 4. Yeah, 5, 3 to 4 is 15. 3 to 5 is 6. 4 to 5 is 8. 4 to 6 is 9. And then 5 to 6 is 11. So, kay Floyd Warshall, para tayo magsiset-up ng adjacency matrix. Pero instead na yung edge yung ilalagay natin between them, ilalagay natin yung distance niya. So, actually, baka mas madali. Ano ba? Susulat ko na lang ba? So, from 0, 4, 5, 7. And kung gusto natin sundan yung algorithm, parang medyo simple lang siya. Actually, check lang natin. From I equals from k from 0 to total vertices, I from 0 to vertices, j from 0 to vertices. Parang ulit-ulitin na natin yung relaxation. So, ito yung relaxation algorithm natin. So, checking. We first update yung distances with yung edges na meron tayo. So, actually, lahat ng edges. So, from 0 to 1. So, let's say ito yung source. Dito yung destination. So, from 0 to 1, it's 7. And then, hindi yung 1 to 0. Ay, parang. So, medyo matagal to. And then, from 0 to 3, 5. And, ayun. Basically, sasabihin mo lang dito, starting from 0 to. Actually, dito, ginagawa niya is meron tayong separate na 2D array for the distances, may separate na 2D array doon sa predecessor or yung previous na node. So, this one, parang pwede mo i-node dyan na from 0 to. And then, next is from yung 1 to 9. Ay, 1 to 3 na 9. And 1, 9. Okay, 1. Wala pa mas may pin. Masulat ko niya. And then, 1 to 4. Dito pa. 1, 4, 7. So basically, after mo ma-set up yung table na to, mag-update lang tayo. So when we want to go from 0 to 3, or yung una 0, 0, 0, so going from 0 to 0 to 0, so basically, k yung nasa gitna, I yung source, j yung destination. So i-compare natin, for example, si 0 to 3 is 5. So let's say yung I is 0, j is equal to 5, and then k is equal to j is equal to 3. and then k is equal to 1. So yung diretso from I to j or 0 to 3 is 5. Pag dumaan tayo ng 1, that is 16. So sino mas malaki? So mas maikli pa rin si 0 to 3. And then, ulitin mo lang yun for every other combination, basically. So parang i-check mo lang din kung si 3 to 4, 15. Pero pag dumaan ako ng 1 and then 4, makukuha ko 16. So mas maikli pa rin. Pero pag dumaan ako from 3, 5 to 8, ang path ko is 14. Pag dito ako dumaan. So, pwede nating i-replace ito. So, yung 3 to 4 natin, 3 to 4. Kung initially, starting from 3, 15 siya, i-replace mo siya with from 5 and then 14 siya. So, ma-update siya, basically. So, yung shortest path from 3 to 4 is actually itong 14. So, pwede, actually, yun yung ginagawa nitong nasa inner two loops. So, check natin kung what if dumaan ako ng 1? So, yun nga, 16. What if dumaan ako ng 6? What if dumaan ako ng 0? So, pag dumaan ako ng 0, kung check natin, ano ba yung distance ni 0 papunta kay 4? So, if defined na yun, probably 14 siya. So, 14 plus yung 5 is 19. So, hindi siya ma-relax. So, basically, ulit-ulitin mo lang, check mo lang ulit for any intermediate na dadaanan. So, from 0 to 2, check mo yung 0, 1, 2, check mo yung 0, 3, 4, 2, 0, 3, 5, 4, 2, 0, 3, 5, 6, 4, 2, using this loop over here. Pero, ayun, arrange siya in such a way na mako-cover because of paano siya nag-work, matitest din yung lahat ng parang possible na combinations. So, of the three, sa Dijkstra, Bellman-Ford at saka Floyd-Warshall, si Floyd-Warshall siya yung parang pinaka-comprehensive. Kasi makikita mo dito, kung yun, starting from 3, gusto ko pumunta kay 4, yung shortest path ko is 14. And dadaan ako kay 5. Tapos, makikita mo nun, pag galing ka kay 5, may entry yon, yung 3 to 5, makikita mo dito na predecessor 3, distance 6. So, parang doon mo bubuin yung path. So, I think pwede mong gawin dito kung gusto mong i-print out. Not sure lang if pwede natin makita. Meron bang adjacency list siya? Si Floyd Warshall. Ayan, pwede natin i-print siguro si distance. Okay, while we're waiting for it to finish. Ay, ba't kailangan ko muna. Okay. Kailangan kong i-run to. And then ito. Ito. And then nag-stick kasi ako. Yeah, so from hindi siya naka-ano. So I think this is directed na graph, kaya ayan, directed edge siya. So may mga instances na merong mga nodes na hindi pwedeng pitahan. And I think si Floyd Warshall din actually hindi siya pwede pag undirected. Not sure. I think maganda lang siya pag directed. I think may modifications pa siya pag undirected. Pero either way, for example, gusto nating from 0 to 6. So parang 0 to 6, 22 yung distance. And yung previous node niya is 5. So para makapunta kay 0 to 5 is, check mo, yung 0 to 5, which is this one, 0 to 11. Ay, yung distance na 11 na dadaan kay yung previous na is 3. So from 3 to 0, titingnan mo rin, 3 is distance 5 from 0. So, ay, nabuo mo na yung 0, 3, and then 3, 5, and then 5, 6. So, doon na siya mabubuo. Ayun. Ay, so in summary, yung tatlong algorithms, ito yata yung pinaka summary natin. So, yung breadth first search is, yun nga, regular queue lang. So, ito lang yung parang pinaka running time ng queue natin, vertices times edges. So, si Dijkstra meron siyang priority queue. So, meron tayong log E na term. And then, for Bellman-Ford, since hindi tayo gumamit ng queue, it just iterates multiple times. It's V squared times E. And then si Floyd Warshall naman, since lahat ng possible na source kino-consider niya is tatlong nested na V. So V cube. So if madami yung vertices natin, may expect natin yung pinaka-pangit na running time is yung kay Floyd Warshall. Kasi nga kino-consider niya lahat ng source and lahat ng destination. So may questions ba tayo regarding yung ating shortest path algorithms? Ayun, parang nakita niyo yung transition natin from yung original na Bellman ay na breadth first search na nagtitingin lang ng mga katabi. So yung breadth first search is starting from the source node is parang mag-hop lang tayo sa mga katabi niya. So para tayong kumakalat basically. And nag-a-assign lang tayo ng distances based doon sa number of intermediate na vertices. And after natin, and para i-consider yung edges na may weight is that si Dijkstra nag-introduce siya ng paggamit ng priority queue. So instead of just yung pinakamalapit in terms of number of vertices, gagamitin natin yung pinakamalapit in terms of yung total weight ng path. So doon natin na-determine kung anong nodes yung kailangan i-visit muna. Then, pagdating naman kay Bellman-Ford, pag nagkaroon tayo ng mga negative weights, kasi, di ba, possible na magkaroon ng path papunta sa node na mas maikli kahit na na-visit na natin siya. So, hindi na natin, parang hindi na tayo magiging tama if pipilitin pa natin na i-visit lang yung nodes one at a time. So, si Bellman-Ford, i-visit niya yung mga nodes depende sa number of nodes. So, kung meron tayong V na vertices or V na nodes, kailangan natin ulitin yung parang breadth first search natin. Hindi mo na siya breadth first search ngayon kasi walang specific order na kailangan. So, parang regular iteration lang siya over all the nodes and neighbors ng nodes sa Bellman-Ford. And then, ayun. And then from Bellman-Ford to Floyd Warshall, basically, ang question na gusto, or yung problem na gustong i-address ni Floyd Warshall is what if iba yung source node na gusto natin i-consider. So, kailangan nating i-check yung parang lahat ng combinations basically ng source and destination and intermediate na node. So yun, I guess we can also look at yung Python na implementation dito sa Colab. So yung first part dito is just a given na minimum heat and undirected na graph. And then, ayun, meron din tayong class for an edge. So for Dijkstra's algorithm, ayan, meron lang tayong additional na array to keep yung mga distances and then yung edges nung previous na para mabuo natin yung path basically. And nandito yung algorithm niya. So, ayun, habang may laman yung ating priority queue, while PQ is size is greater than 0, kukunin mo lang yung smallest and then ma-mark mo siya or revisit mo siya. And then itong scan, ito na yung pinaka-relaxation algorithm natin. So, yun sa Dijkstra. Pag sa Bellman-Ford naman, same din yung, ayan, meron tayong distance na list and then meron din tayo yung edge 2 na list. So, this lists down yung ano yung mga edges na dinaanan. And yung shortest path algorithm niya, yun nga, si Dijkstra gumamit siya ng priority queue. Si Bellman-Ford is hindi na siya gumamit ng priority queue. Nag-iterate lang siya over each vertex and each neighbor ng ating mga vertex. Tapos nag-relax, ginamit na lang yung relaxation na algorithm over here. And then kailangan mo lang siya ulitin multiple times para lang para ma-make sure na wala nang nag-update. So para siya actually bubble sort. Pagka nirun mo tong inner for loop na to and walang nagbago, pwede na actually tumigil yung algorithm. Pero ay pwede nyo ring isipin na for the Bellman-Ford, after one iteration, sure ka na lahat ng immediate neighbors ay tama na sila. And after another iteration, you are sure na after yung two vertices away, tama na rin yung mga vertices or tama na rin yung mga weights niya. Actually, you can look at that here. Pag nag-Bellman-Ford tayo kay 0. So yung first iteration natin, ito yung magiging result pag na-visit na lahat ng vertices, di ba? So yung sure lang tayo na shortest path is yung mga immediately nakatabi niya. And then actually hindi pa ganun ka-sure itong 2. Pero itong 16, siya na yung sure. And then after another iteration, sure tayo na may dalawang tama, si 1 and si 2. So lahat ng iba dito is hindi pa tama. And then after another iteration, is si 3 naman yung magiging tama. So I can say na after each iteration, may isang vertex lang tayo na sure na tama yung distance. And then kaya kailangan natin siya ulitin up to, kung ito is meron siyang 10 nodes, kailangan natin siyang ulitin 9 times para tama yung distance natin after 9 na hops basically, or 9 vertices dun sa path. Then ayun, lastly dun sa Floyd-Warshall is for every starting and ending, check mo yung pwedeng intermediate nodes between them. So kaya magiging b squared, b squared, b squared. Tapos relaxation algorithm pa rin yung sa gitna. So, may questions ba tayo dun sa materials? So, medyo pabalik-balik ako. Ayan, so actually I'm getting a lot of questions similar dun sa nag-chat, which is on kung pwede bang gamitin yung code na binigay dito sa module para doon sa mga exercises. And the short answer is yes, pwede nyo silang gamitin. Actually, tingnan nga natin yung mga exercises natin. Kaya ako rin nabanggit, or I guess sa mga nagtatanong, yung second half ng course natin medyo mas madali siya sa first half ng course kasi marami nang given sa inyo. Tingnan natin sa hacker. So first one is 11B. So this is medyo real life application ng shortest path. So this one is just minimizing yung latency between, I think, access points or between clients and servers. So parang ayun. So usually gamers gusto natin low latency, so each edge is directed. So the links are at the same time, each links. So yung links natin between access points provides a constant latency. So your goal is to determine the total latency to take if you use the shortest path route from your location to any other client server in the network. So basically, kailangan mo lang mahanap yung latency from your server or your computer to yung server na gusto mong connectan. Then yung ating nodes dun sa ating graph ay possibly routers or access points. And yung edges natin between them, yung weight niya is dependent doon sa latency na ini-introduce nila. So basically, I think this is yung number of vertices, number of edges, and then the number of queries. So, ayan. So ito yung network natin. So from 0 to 3, so meron tayong 11 edges yata dito. This is yung source, yung destination, and then yung latency niya. So, excuse me. So basically, ito yung edge list ng ating graph. And then, ito yung mga queries natin. So each query assumes na kunwari, query is 0, starting from kung ikaw is nasa, ikaw yung node 0, gaano ka kalayo kay node 0? So 0 lang. So, kung yung si node 0, gano'n kakalayo kay node 6? So, 22 yung magiging sagot. So, ayun, it's up to you. Meron kayong tatlong choices, or technically 4, pero hindi given yung breadth first search. So, meron kayong tatlong options to use. Yung Bellman-Ford, and Floyd-Marshall, and yung Dijkstra. To determine kung alin yung best algorithm to apply to this problem. So, ano ba yung characteristics ng problem? So, it uses, may multiple queries siya. So, and then, wala, I think, yung latency is, wala naman tayong negative na latency. So, ayun, kayo na naman. Ayun, so if pag nakapili na kayong gustong pagbasehan na algorithm, pwede nyo naman siyang copy-paste dito. And ayun, make the necessary adjustments to conform to the input format and yung sa output format natin. So actually, yung challenge dito is paano mo to gagawing graph and paano mo siya isasaksak doon sa algorithm natin. So ayun, that in itself is yung pinaka-challenge. And ayun, ang suggestion ko lang, kunwari, ka-copy-paste nyo to. If meron kailangan i-modify nyo. And ayun din. Tapos yung pinaka-input and output management, siya yung pinaka-contribution nyo dun sa code. So, ayun. If sa tingin nyo meron kayong pwedeng i-modify dito sa loob para mag-improve siya, okay lang din. If wala, okay lang. Pwedeng bumawi doon sa other parts ng code para magmukhang iba doon sa other students. So, ayun. So basically, yung short answer is yes, pwede nyo gamitin yung code na nandito for week 11 and 12. And actually, yung future exercises din, if ever. Pero yan, yung setup ng graph is completely up to you. So pwedeng edge list lang siya, store mo, pwede rin gawin mo adjacency matrix, pwede mo rin gawing adjacency list. So just make sure na pag niran mo yung code mo, it's within yung time and space na allowable sa HackerRank. So I think hanggang 500 kilobytes yata yung pwedeng gamitin, and then up to 10 seconds yung ating running time. So yun yung C11B. So C11C naman, so wormholes. So ayun, Guardians of the Galaxy. So ayun, basically nagta-travel lang in space, pero pag nag-travel in space is jumping from each wormhole to another wormhole. And then, since wormholes yon, medyo weird yung time. Pwede kang madagdagan ng time, pwede kang mabawasan ng time. So parang meron siya tinatawag na time offset. So in this one, ano ba yung differences ng dalawang problems? So in this one, each edge is directed, and this one, each edge is directed as well. So one direction lang sila. But yung ating pag-travel from wormhole to wormhole is possibly maging negative yung time. So parang parang nag-skip ng time zone basically. So kung nasa Philippines tayo +8, pag pumunta ka sa may England or England na GMT +0, parang mag-move back in time ka by 8 hours. So ayan. Think of it as something similar doon. So basically, find yung ating fastest na path. So parang kung Thursday ngayon, kung merong path na pwede kang daanan in such a way na maging Wednesday yung araw, yun na yung shortest path mo. So, ayan. And may additionally, yung queue lines natin, kailangan natin ma-determine. So, ano yung sources and ano yung destinations? So, basically, iba-iba siya per sample input. So, basically, in this sample, may 10 queries siya. So, from 0 to 3, ano yung shortest path? From 4 to 1, ano yung shortest path? From 1 to 4, ano yung shortest path? And so on and so forth. So, ayan. For week 11B, so something to identify is pare-pareho yung sources natin, pero iba-iba yung destination. And then for 11C is iba-iba yung sources, iba-iba din yung destination. And then, I guess hindi lang kita sa sample, pero wala tayong negative na weights dito. Pero for the other test cases, meron negative na inputs. So yun, among the given shortest path algorithms, alin sa tingin niyo yung pinaka-appropriate for 11B and 11C, and then modify them accordingly to fit yung ating input and output format. So yan. And if sa tingin nyo yung binigay na shortest path algorithms hindi enough, kailangan yung gumamit ng algorithms ng ibang tao, just be sure to properly cite them in your code. So parang sa sagot natin sa HackerRank, pwede mo lagyan dyan, code derived from someone, algorithm from Geeks for Geeks. Tapos yung URL niya. So yan, parang lagay mo lang dyan na comment. Pag ginamit nyo rin yung nandito sa code, pwede nyo naman lagay code derived from week 11 shortest copy ito. Google Colab. And bala na kayo. So, ayun. Basically, yung gusto lang nating sabihin is pag meron ka nilagay dito, sasabihin mo pag hindi siya galing sa'yo or galing siya sa internet. Para lang. Because that is the right thing to do. Ayun, meron ba tayong other questions? Actually, yun na yung week 11. Inom lang ako tubig habang magta-type kayo ng question. And apart from dun sa dalawang exercises dito, meron pang isang summative quiz or graded quiz on Uble. So 11A. So you have 3 attempts. Actually, hindi ko pa na-preview yung questions. So, and there's a 30-minute delay between first and second attempts and a 1-hour delay between the second and third attempts. So, siguro parang if gusto mo siya i-cram by the end of the week, make sure to start at siguro 3 hours before yung deadline para ma-utilize nyo lahat ng attempts nyo. And I guess yung major question din naman na madami rin nagtatanong on Discord is yun nga, you can use yung ating provided na source codes for the algorithms dun sa Colab notebook. But be sure to cite them and make as much modifications as you can. So, ayun. And may nagtatanong din if gumamit ng materials na given doon sa lesson, kailangan ba siyang i-cite? Actually yun, hindi nyo na kailangan i-cite since diniscuss naman natin in class. Pero if meron something or may extra concept kayo na ginamit na hindi pinag-usapan in class, that would be the time for you to add a reference. So basically, kung wala, nagsasagot kayo ng program, nagsasagot kayo ng quiz, nagbukas kayo ng ibang website except Uvle or yung links na provided sa study guide, kailangan nyo siyang i-mention. So, pwede nyo i-assume na yung submission nyo, cited na yung lahat ng materials natin. So, yan, parang may citation na lahat ng materials natin and lahat ng links na pinopost sa study guide. So, pag meron kayong ginamit na link or web page na wala dito sa study guide, you should add a citation or add it as a reference to your work. So, ayun. Then, ayun, actually, dino-double check ko kayo kasi meron akong mga ibang students na inaabangan mag-attend kasi may kailangan akong itanong sa kanila. Pero wala naman for this session. So, if wala nang questions, wala na nga ba? So, after this session, I'm assuming dalawang meeting na lang or dalawang synchronous session na lang. And then, hihiwalay na tayo ng landas. Ayun. So, kasi dalawang meeting na lang. So, yung next meeting natin will be on week 12. And the meeting after that, which will be the last meeting, will be on the software project na. Ay, gusto niyo pala ng preview ng software project niyo? Dahil natuwa akong gumawa. Saan ba? Hinahanap ko pa yung file. Ito. Yan. Ba't parang bitin? Ay, ito pala. Yung buo. So basically, ganito yung magiging itsura. Although hindi naman, ito yung solution. And so nakikita niyo ba yung graph dito? Paano siya magiging shortest path? Pero anyway, ayun, yung full specs will be released tomorrow. So stay tuned for that. So, ayun. If there are no more questions and comments, I think we're done for today's session. Thank you very much for attending the class, and I'll see you next week.